I've been using John Bedini's SSG circuit on a few of these different builds, and got some pretty neat observations I'd like to share with you. Hope you find something interesting here. This is the PC fan version. Over here I've built a couple of the relay versions. Won't be showing those, they just make too much noise. Here's another PC fan version of the SSG, and we'll be looking at it in a little bit. And there is the stepper motor build, and got some fun stuff to show as well. So let me get this first little experiment set up and we'll get started. Thank you. Okay, here's my first little setup, and I've already got this little fan running. It's running off of a 12-volt battery. It's I know it's hard to see on the meter, but it's currently drawing just under 70 milliamps. With the pot, you can adjust that. I can draw this all the way down 55, 60 milliamps. I'm going to set it back closer to the 70, and let's set this first experiment up. I've got a capacitor here, and this capacitor is a 43 to 53 MFD 220 volts AC. And what I want to do is throw a charge in here. Okay. Remember, I'm running 12 volts, and so let's get this started here. And watch my my voltmeter here. We're going to turn it up, and let's go ahead and get it started. And there it is, filling up that cap. We're at 148. It'll take just a few minutes. It's up over 200 volts now, and this is on the DC setting. Okay, I'm not going to let it go any higher. It's at 220 volts. This thing will run up to about 250 volts. So I'm going to pull this off of here. And before I hurt myself, I'm going to discharge that capacitor. Alright, so you can see it did have a charge in it. Okay, this fan's still running, and still pulling right at 70 milliamps off that 12-volt battery. So here was something I thought was kind of fun. Notice it. This is an unmodified LED, AC LED. That's no modification. I'm just sticking it to the. And here's a different kind. This one's a GE. That was a Fiat. There we go. Now look at my current draw. Now it's running below 65 milliamps, so it dropped a few milliamps. Let's see if it did that to this one. Now, this one does not seem to affect the current draw, but this one does. All right. Thank you for watching that, and we're going to look at the stepper motor next. The last time I showed this stepper motor wired up to the John Bedini SSG circuit, I didn't have any loads on it. And so first thing I want to do is put a light output load on this. And so let's start this up, and I think you can hear that it's running. And right now it's drawing right at 100 milliamps. Let's put a little load on it here, and there we are. This is a GE light bulb, and that changed my current draw. I'm just right under 120 milliamps. Okay. Now, this is something that I thought was quite interesting. Let me take this bulb out and put this one in. Excuse me for reaching across. Look at that one. It's not lighting. So, let's take this out of here. And I'm going to stop this just a second. And here I have just a transformer out of a power supply. This is a 5 volt, 400 milliamp power supply. Came out of this right here. So this was weird because when I took it out, I didn't see any of the diodes or transistors or anything on this. It was just what you see. In fact, here's the plug-in part, and here are the DC 5 volt DC wires coming off. Okay, so now let's hook this back up, and I'm going to start this back up. There we go, running through that transformer. Now my current draw is right around 180 milliamps, so I did increase my current draw. Give you an idea, here is the same bulb plugged into the wall, and I'm going to darken this room just a little bit so you can gauge the output of the light. These are identical bulbs, pretty close. And again, that's running off of a 180 milliamps 12 volt power supply, or 12 volt battery rather. Okay. Alright, here's the same setup going again, using two different bulbs. These are two Philips LED bulbs, and so they behave very, very similar to the other bulbs. Now, what's very interesting about these is that these are 3-watt bulbs, and let's check my current draw. And right now I'm running about 175 milliamps. So that's pretty impressive. Okay, I took the transformer back off, running just a GE LED off the plug. And now I've hooked a fan up to it. So now I've got a load with the light and with the fan. And so here, it's not putting out a lot of air, but it is putting out air. So now I'm capturing energy from both sources. Okay, so I've removed the fan. And now I've got just the stepper motor with a belt to this old CD-ROM or CD drive motor, and we're going to spin that up. Whoops. Well, let's try that again. There we go. Now, the more pressure I put on this belt, more tension, it does drive the current up. I'm running about 160 milliamps right now. So, I thought that was kind of neat. Alright, I've replaced that pulley and belt with a wooden ball that has 4 magnets in it. And so now I'm spinning a magnet. And the reason I'm doing that, I wanted to show you how this gearing is working. There I'm at almost 90 degrees, and it's hooked up pretty well. Now I can also take that, and here's a solenoid. Let's just do it here first. And there's a little ball bearing inside there. I think this came off an old printer or something. I put 2 LEDs on there, and I don't know if you can tell, but I tried to color. I'm capturing the DC coming off of either end of this coil, and you can tell I am because both LEDs are flashing. But again, here's the magnetic coupling. Okay, I hope you're able to see this. This is another setup. I've got another wooden ball. This time it's connected to a CD motor, and it's magnetically coupled, and it's running to this steel wire pancake coil Jewel Thief by Lid Motor, and you can see it is blinking the light. Let's oh, lost my coupling there. Well, there, it's up and running again. And it'll put out pretty good light.